For learning assessment 9.10, problem statement is an industrial load consumes 100 kilowatts at 0.707 power factor lagging. The 60 hertz line voltage of the load is 480 at an angle of 0 volts RMS. The transmission line resistance between the power company transformer and the load is 0.1 ohms. Determine the power savings that could be obtained if the power factor is changed to 0.94 lagging. Okay, so let's look at a circuit diagram for our case. So we have a source there we'll represent with Vs. Okay, and our resistance there, the 0.1 ohms, that's the transmission line resistance. Okay. Now, we have the power for the load. So we know, for instance, that P sub L is 480 times I1, and let's define I1 on the circuit in this direction times the power factor. So now we can solve for I1. The PL is 100 kilowatts divided by 480 times 0.707. That's 294.7 amps RMS. So the power for the source then is the load power plus the power loss in this line. So the load power is 100 kilowatts plus 294.7 squared times 0.1, and that's 108.68 kilowatts. Now let's go through and do the same calculations, but let's look at what happens if the load power factor were to be changed to 0.94. Okay, so here's our same situation. Again, we'll look at the current I1. So now I1 again is, we have 100 kilowatts. We have 480.94. So you can see now we have 221.6 amps RMS, a significant reduction in the current magnitude. So now our source power is 100 kilowatts plus 221.6 squared times 0.1, which is 104.91 kilowatts. So our power savings by operating at the higher power factor is 108.68 minus 104.91, which is 3.77 kilowatts.